Winter, 1944, Anzio, Italy. German artillery held the high ground, a perfect field of fire over the Allied beachhead. Their victory was guaranteed by steel and mathematics. It was nullified by a social catastrophe hundreds of miles away. Batteries of 170mm artillery could hit anything that moved. Supply ships, trucks on the roads, men in foxholes. The gunners opened fire. Then, a dull thud. A 60-kilogram slug of steel hitting wet earth. No detonation. Why did Europe's most advanced war machines suddenly start firing useless slugs? The answer was buried in the Italian mud. American combat engineers waded through the battlefield. They gathered the duds. They cataloged the pristine, untouched fuses. The shells were then packed in crates, destined for analysis in Washington. The scale of the failure was not a rounding error, not a single bad batch. Historian Jeffrey Parrott documented the numbers from Anzio. 7 out of 10 heavy shells were defective, a systemic breakdown. Each dud was a monument to wasted industrial calories, the steel, the logistics, the man-hours, all for nothing. The pattern became undeniable. This was not a technical problem. Post-war Allied ordnance analysts confirmed the source of the defects originated on the factory floor, from the hands of forced laborers. The sabotage was a symptom. The disease was systemic. By 1942, the Reich faced a demographic crisis. The war on the Eastern Front had consumed manpower at a rate no plan anticipated. Wehrmacht losses exceeded 1 million men, a gap that had to be filled. The replacements came from the factories, skilled workers, tool and die makers, chemists. They were pulled from assembly lines, drafted into uniform, and sent east. Millions of them. Albert Speer, Minister of Armaments, saw the raw mathematics, an unsolvable problem. Guns needed shells. Shells needed skilled workers. Germany was running out of both. The factory floors emptied. Albert Speer understood the catastrophic price of this mobilization. He knew that in 1939, a completely different social caste stood at the machines. So where did the textbook reliability of ammunition come from at the beginning of the war? It came from a culture of precision. A German quality control engineer pulls a casing from the production line. He compares it to the master blueprint, measures tolerances to the micron. Any deviation is a failure. He chambers a cartridge into a test rifle. A sharp, metallic click. Perfect fit. This was the standard. This standard was built on a specific social asset, the German skilled worker, the turner, the chemist, the machinist. Each required 3 to 4 years of rigorous apprenticeship, a social capital that could not be replaced quickly. Their professional pride was measured in millimeters and milligrams. This system of precision fueled the early campaigns. Poland, France. The Wehrmacht's blitzkrieg relied on equipment that worked. Shells that detonated on contact. Rounds that penetrated armor. Cartridges that cycled in mud and ice. This absolute standard of quality held for 2 years. But that standard of quality held for only 2 years. Then it broke. In its place, millions of captive workers. The architect of this new system was Fritz Sauckel. Appointed in March 1942, his objective was simple: fill the factories. His program would process 15 million men and women, a captive population larger than the entire nation of Belgium, fully integrated into the Reich's economy. The method was systematic abduction. Armed guards unloaded people from cattle cars. The exhausted were marched straight to barracks. These camps were built directly against the walls of clean, high-tech production facilities. The smell of unwashed bodies and camp stew seeped into sterile chemical workshops. The contrast was absolute. These workers received rations below subsistence levels. They were ordered to assemble high-precision fuses. By the war's later years, forced labor constituted 20% of the entire German workforce. In the armaments industry, that figure was 1/3. The vast majority were Slavic, Poles, Russians, Ukrainians, designated subhuman by Nazi racial doctrine. They were worked to death, then replaced. At the Nuremberg trials, Sauckel admitted to the program. He confirmed the brutal measures against unproductive workers. He had approved it all. The first mass reports on defective ammunition landed on the desks of the High Command. Sabotage was not stolen blueprints, not a factory in flames. It was a quiet war fought in millimeters. The technical tolerance became the weapon. How do you resist a system that beats you to death for slowing down? You work at the lowest possible edge of the engineering specification. A worker stands at a press. His daily ration, 600 calories. Less than 1/3 of the basal metabolic rate required for heavy industrial labor. The foreman turns his back. The worker measures a powder charge by eye, not by scale. He crimps a detonator cap, a fraction of a millimeter too loose. The metallic click is weaker than the technical requirement. Individually, it was imprecise work, the result of an exhausted, unskilled laborer. Systematically, it was a weapon. A batch of artillery shells leaves a factory with a defect rate of 15%. The acceptable norm was 2%. That ammunition travels to an artillery depot in Italy. It is loaded onto German guns in the hills above the Anzio beachhead. The order to fire on the Allied positions is given. 7 out of 10 rounds landed in the mud as inert steel. The shells manufactured to a compromised tolerance reached the front lines. By the end of 1942, they were jamming the breeches of panzer cannons. The reports became systematic. Artillery batteries documented dud rates higher than any acceptable parameter. Infantry units reported small arms cartridges that misfired or failed to cycle. Panzer crews logged rounds that did not meet specified penetration depths. The data was consistent. This was not the Wehrmacht of 1941. The army that launched Operation Barbarossa did so with absolute faith in its engineering. That trust was now eroding. The psychological effect of a misfire in combat reduced a unit's real-world rate of fire as crews lost confidence in the weapon itself. The German soldier at the sharp end had no way of knowing the cause. He only knew his weapon was failing. The mistake on the factory line was a death sentence, a hanging, executed at morning roll call in the cold wind of the camp parade ground, a warning to the rest. Why did these exhausted civilians risk the noose? For a specific purpose: to embed a systemic defect into the very structure of German firepower. The method was statistically invisible. Gestapo inspections could not detect 1 missing gram of powder among millions of rounds. Polish workers falsified the measurements. Osterbeiter, the Eastern laborers, packed explosive charges with insufficient filler. Post-war archives proved it. The failures had a source, and that source had names. Czech prisoners went further. A worker writes a note. He folds it small. He slides the paper into an empty shell casing. The casing is sealed on the conveyor. A message for a future that might never come. This was not random error. It was organized war, fought by unarmed men and women. The weapon was breaking from within. In Europe, production was a battlefield of sabotage. Across the Atlantic, it was a problem of engineering. The center of this problem, Waterbury, Connecticut, the brass capital of the world. Before the war, its factories made buttons, cocktail shakers, lipstick holders. Its workers were Italian, Irish, Swiss. Immigrants who collected a wage and went home for dinner. They had no reason to break what they built. How did a peaceful city of buttons and clocks become a global arms factory in months? The answer was conversion. Mattituck Manufacturing stopped making upholstery nails. The old presses were retooled. The same monotonous clang now stamped out cartridge clips. Clips for the M1903 Springfield rifle. Within months, Mattituck produced 3 million clips a week. The entire city pivoted. Chase brass and copper switched from plumbing fixtures to ammunition. Over 1 billion small-caliber bullets. The population was just 100,000, but one factory's output could supply a field army. 3 million clips a week. 50 million cartridge cases. 2 billion pounds of brass from the American Brass Company. This was the technical volume of a single town, a town built on a social contract. Workers had union representation, cafeteria lunches, bus routes named after the plant. They were paid. They ate. Their families were not in camps. At the end of an 8-hour shift, workers punched out and returned home. Waterbury was not an exception. It was one node in a national production system, a network stretching from Connecticut to Texas. The St. Louis Ordnance Plant was the mechanism. It ran 24 hours a day, 7 days a week, 35,000 workers. Half of them were women, a demographic shift engineered for continuous output. They worked night shifts, early mornings, long midday hours. The result was 250 million cartridges per month, over 8 million rounds, every single day. A logistical figure unattainable for a depleted German industry. This system was not just about scale, it was about speed. In Evansville, Indiana, the Army issued a new directive: switch from brass casings to steel, a process no one had perfected for mass production. Engineers received the new drawings. Within 1 week, they formed the first steel cup. 2 weeks later, they proof-fired the first finished rounds. This social foundation guaranteed every round for an M1919 Browning would function. The German system was different. By 1943, it was beginning to consume itself. Expectation: flawless quality from Germany's best engineers. Reality: systemic failure built into the production line by slave labor. Why did perfectly designed German shells fail at the most critical moment? The reason is not metallurgy or engineering. The reason is social mechanics. A Wehrmacht artillery crew in the hills above Anzio depended on these shells. Shells loaded by Polish prisoners. In a factory outside Warsaw, these workers were not building a future. They knew they were digging their own graves. So the official German inspection stamp was applied to a lie, a seal of approval on a dud, a guarantee on a product designed to fail. The German soldier in the gun pit trusted his equipment. He could not know the system behind it was built on terror. And that terror had a technical cost. In a foxhole, a gun crew had no way to fix a faulty shell. While one system manufactured failure, another built certainty. In Waterbury, Connecticut, a woman named Rose began her 12-hour shift. Her hands checked the tolerances of a brass shell casing, a perfect fit. A machine tamps the powder charge by specification, the sharp chemical smell of a sealed propellant. Somewhere in the Ardennes, a soldier loads that exact round. It will fire. Rose was one of 3 million workers. Her brother was fighting in Italy. Their motivation was not a supervisor, it was survival. Their survival. What social force can collapse the technical efficiency of an entire army? The answer is not found in logistics, it is found in the reason for the work. Albert Speer saw production quotas, Fritz Sauckel saw units of labor. Neither saw the poison in their own system. The math was brutal. 70% failure at Anzio meant for every 10 German shells fired, only 3 detonated. A battery's firepower was reduced before the battle even began. This was an asymmetry Albert Speer could not see in any production report or summary. It was the war fought on the factory floor. One side built by free labor, the other by slaves. One side was paid in wages, the other was paid in terror. At Anzio, the result was a technical specification, a dud rate of 70%.